In section 4.3.1, we're looking at polynomial long division. The trick with this polynomial long division is practice. So I want to make sure that you have taken the time to do the pre-lessons, which there's a math is fun, a couple math is fun activities with long division with numbers. Make sure you remember how to do long division, and polynomial long division. So it's got some good examples in there. And then also the pre-lesson assignment quiz. So I want to make sure that you see those examples too. So division has a lot of different things. So I kind of picked a tricky one here where after you've seen Math is Fun lessons and the pre-lessons, you would have already been exposed to without remainders, with remainders, needed to plug in some zeros for missing pieces. So I'm going to do a harder one here where we have a remainder and we also have some missing pieces. So when I do division, at long division, I always set it up like this. I say the quotient goes over here. I'm sorry, the divisor goes over here, and then I do a big division bar, and I have my dividend in there. But if you watched your pre-lessons, then you'll know, something's missing here. I have to have every term of that polynomial listed, even if it's a 0. So if I have a third degree polynomial, then I want an x cubed, x squared, x, and a constant. It's going to have 4 terms. So I'm actually going to rewrite this guy. Instead of x cubed minus 8, I'm going to do x cubed plus 0x squared plus 0x, and then the constant is 8. So notice that those are equivalent polynomials. I just put in the 0 to hold as a placeholder for the x squared and the x term. So that way, under my fraction bar, I have x cubed plus 0x squared plus 0x minus 8. You may have seen some 0 placeholders in the divisor. I don't think that's necessary, so I usually do not do that. So I'm just going to keep it like this. And as long as I have my zeros on my quotient, so I make sure that if I do end up with an x squared term or an x term, it has somewhere to go. All right, so now for our division. So I always look at my leading terms. So I think, how many times does x squared go into x? Or in other words, what do I multiply by x squared in order to get that x cubed? And I need another x. So I put an x here, and then I do x times x squared equals x cubed. And I say x times the negative 2 gives me, make sure I put it under the same, I want to line it up. So it's not an x squared, it's not an x, but it's a constant. So, I'm sorry, it's going to be an x. So negative 2x. So I've got negative 2x. So when I multiply that x by, where'd it go? X squared minus 2, I got x cubed minus 2x. And then I want to subtract that whole line, so draw the line and change the signs. And I get the x's will go away, and that first term should always go away. That's how by design, that's how I picked that piece right there. And if it doesn't go away, that means I made a mistake. And then there's nothing there. So, and then I have 0 plus 2x is going to give me 2x, and then I'll bring down my negative 8. And then I have my next term. I want to say, okay, now what do I need to multiply x squared by in order to get 2x? Well, I can't multiply x squared by anything to get 2x. X squared doesn't go into 2x. So that is my remainder. So my remainder is, I'm going to put the remainder as 2x minus 8. And my quotient is x with the remainder of 2x minus 8. I can also express this final answer as x plus the remainder, 2x minus 8, over the quotient. I'm sorry, the divisor. So there's one way to express the final answer. And there's another way to express that final answer with the remainder. Let's look at a second example that has a few more of the steps and they don't get to the remainder quite so fast. So again, we have some zeros we're going to have to fill in as placeholders. So I always do the divisor first. But the dividend I have to rewrite so that it has each term. So 6-degree polynomial, so I'm going to need an x to the 6th, 5th, 4th, 3rd, 2nd, 1st, and a constant. So it's going to have 7 terms total. So I'm going to rewrite that as x to the 6th, and then I don't have an x to the 5th, and I don't have a 4th, I don't have a 3rd, 2nd, 1st, and I do have a constant. So I'm using those zeros as placeholders because my quotient just might have those terms, so I need to have a space to put them. So I'm going to stick that expanded dividend in here. It's so long, in fact, that I'm going to have to extend my divisor line. Dividing line. Okay, there we go. So the first step is always looking at those leading terms. How many times is x going to x6? In other words, what do I need to multiply x by to get to x to the 6th? So the answer to that is x to the 5th. So I take my x to the 5th and multiply it by x minus 3, and I get x to the 6th minus 3 times x to the 5th. So that needs to line up with the x to the 5th, so that's going to be minus 3x to the 5th. And I don't have anything for the 4th, 3rd, 2nd, x, or even the constant. So that's okay. So those are all zeros. So then I draw the line and change the sign. So I want to subtract that green from the purple. So draw the line, and then I'll change the sign on both these pieces so I don't forget to subtract on both of them. And then I get this first term better go away. If it doesn't go away, then I did something wrong. My second term is 0 plus 3 is 3. My term is x to the 5th. And the other ones, I'm not subtracting anything from them, so I can just drag them down. All right, now to my next term. I say what times x will give me 3x to the 5th. And the answer to that is a positive 3x to the 4th. So I'm going to multiply 3x to the 4th times x minus 3 and put that answer over here. And I want to make sure I line up my terms, my common, what's the word? Like terms. So 3x to the 4th times x gives me 3x to the 5th. And then 3x to the 4th times negative 3 gives me a negative 9x to the 4th. So that's going to go right here. I don't have a third term. I can actually write zeros in here like I just was about to, or I can leave blanks like I did up here. And just remember, I'm not subtracting anything. So now to subtract the blue from the green, I can draw a line and then change the sign. I like to change the sign all the way through so that I don't forget that I'm subtracting. Okay, so then 3x to the fifth minus 3x to the fifth, those better cancel. If they don't cancel, I did something wrong, but they do, so yay. And then 0x to the fourth plus 9 gives me 9x to the fourth. And 0 minus 0 gives me nothing. So I have a 0 for the third term, the squared term, the linear term, and the constant is negative 27. All right, let's do that again. Now I want to ask myself, what times x is going to give me 9x to the fourth? So that is a positive 9x cubed. So I take my positive 9x cubed and multiply that by x minus 3, and what do I get? 9x to the fourth, and then 9x cubed times negative 3 gives me negative 27x cubed. And then I want to subtract the orange from the blue, so I'll draw the line and then change the signs. And the first term needs to cancel out, and it does. And then I have 0 plus 27 gives me 27x cubed. And then drop down the rest. All right, let's do it again. So now what times x is going to give me 27x cubed? And that answer is 27x squared. So then I multiply that 27x squared times x minus 3, and I get 27x cubed. And then 27 times a negative 3 gives me a negative 81 x squared. That goes in this x squared place. And then I don't have an x term. So draw the line and change the sign to subtract. And the first term better go away, which it did. And then I have 0 plus 81 gives me 81x squared. And 0 plus 0 minus 0 gives me 0. And so let's copy that down. And the negative 27 comes down. All right, I'm getting closer. So now I want to ask myself, what times x is going to give me 81x squared? And that's 81x, so I add 81x, and then I multiply 81x times x minus 3, and I get 81x squared and then 81 times 3, that's 243, and that's 243x, so that's going to go in the x under the x, 243x, and it's negative. And then I draw the line and change the signs, and the first term goes away, and then I get 243x, drop down the 27, and then I ask myself, okay, now I'm almost done. Running out of colors, just a long one. And I say, okay, what times x gives me 243x? And that one is 243. So that times x minus 3 gives me 243x. 243 times 3 gives me 700 and something. That gives me 729. Feel free to grab a calculator for that. I prefer to just do a little side note there. So that gives me negative 279. No. Yes, that's right. Okay. And then when I draw the line and change the signs, the first term drops out and I get a positive Oh, whoops, that's not 279. Sorry, that should be 729. 729. I get a positive 702. And then when I ask myself, okay, how many times does x go into 702? I say, wait a second, x doesn't go into 702. I'm done. I have reached a remainder. I've reached a point where I can no longer get my x into this number. 702 is smaller. So that means I have a, this is my q of x function, and my remainder is 702. I can also write that as adding 702 over x minus 3. So two different ways to write that. Either write, if depending on your instructions, if you're asked to find a function for the remainder, do 702. And yeah. So actually I did some mixed messages here. So I will take off that quotient, q of x. So this is the whole answer with the remainder written as part of the answer. But if I'm asked to separate the remainder and the quotient, then the remainder is 702 and the quotient is x to the 5th plus 3x to the 4th plus 9x cubed plus 27x squared plus 81x plus 243. All right, that's a long one. And there's actually an easier way to do this one, which you might remember from your pre-lesson. So this one is special because I'm dividing. My divisor is of the form x minus a constant. If I have a divisor of x minus a constant, I can use an abbreviated division. So this is long division, and you can see that why it's called that. It's quite long, and we had to have all those terms in there. A lot of dividing and asking how many times does it go into that, and then subtracting, divide, subtract, divide, subtract, and it's long. So I'm actually going to use synthetic division since I have this simplified factor. It's a linear factor where I have the form x minus a. If I have that form of, this has to be a 1, it has to be linear, so I have x minus a, then I can use synthetic division, which uses multiplication and addition, and also you just write the coefficients. So it's an abbreviated version of this long division. So let's do the same problem using synthetic division and see what we like better. So we did x minus 3 was our divisor. I'm going to write example 3 here. So with synthetic division, I still have to have all the terms. So if I have a 6th-degree term polynomial, I still need to find a way to express that with all 7 terms and use zeros as placeholders. So I'm going to rewrite this as x to the 6th plus 0 times x to the 5th, 0x to the 4th, 0x to the 3rd. This is the same thing we did so far as the long division. And then a minus 27 is my constant. And then now I'm going to divide by x minus 3. And so instead of doing my division bar, what I'm going to do is, this is synthetic division. Instead of doing x minus 3, I'm going to just use the 0. So if the factor is x minus 3, then the corresponding 0 is 3. Remember, if I set that x minus 3 equal to 0, I get x equals 3. So that, my 0 goes on the left-hand side. And on my right-hand side, then I draw this kind of bar that has 2 lines space for 2 lines of writing, and a big long bar. So it's almost like an upside down division bar. And then instead of writing this whole polynomial, I'm just going to look at the coefficients. So I know I have every term listed. So I know that I have a 0 for placeholders. So I don't have to worry about like what, I'll just take the coefficients and I'll put them back in later. So my coefficients here are, there's an understood 1 there, and then a 0, 0, 0, 0, 0, and a negative 27. And I know that represents this. Okay, so now I'm doing, the synthetic division is very procedural. So you memorize this procedure, but it makes it easier because it simplifies it, gets rid of all those, a lot of the pieces. So it's just those, just the coefficients. And it does addition, multiplication, addition, multiplication. So the first step of synthetic division, actually the first step is this setup where we write the 0 and the coefficients. I should probably write that somewhere, huh? So step 1, use 0, and then use coefficients. Use 0 of divisor. Use the coefficients of the dividend, the expanded dividend, where we have all the terms. And then I drop down the first term and just bring it down, 1. And then I want to add and multiply instead of divide. So I go 3 times 1 equals 3, and I put it there. And then I add. 0 plus 3 gives me 3. And then I do 3 times 3 gives me 9. And then add. And I get 9. And then I do 3 times 9, and I get, put that there, and I get 27. And then I do 27 times 3, which gave me 81. And then I do 81 times 3, and I go 243. I'm just adding, multiplying, adding, multiplying. So now add the 0 and the 243, and I get 243. Now do 243 times 3, and I get 7. I got a little ahead of myself there. Let me back up a few. In fact, let me just start over here. So bring down the 1, and then we multiply these two numbers together and put that number there. And then we'll add these two numbers to put that there. And then we'll multiply and then add. And then multiply and then add. So some repeated addition and multiplication. So starting with 1 times 3 to give me a 3 here. And then I add the 0 and the 3 together, and I get 3. And then I do this number again. The 3 times 3 gives me 9. That 9 goes here, and then I add 0 and 9 gives me 9. And then I do the 3 times 9 gives me 27. And then 0 plus 27 gives me 27. And then 3 times 27 gives me 81. And that gives me 0 plus 81 gives me 81. And then 3 times 81 gives me 243. Then 0 plus 243 gives me 243. And then 3 times 243, that gave us 729. We found that out when we did the side work over here somewhere. Let me just double check that. Yep, see? 243 times 3 gives me 729. And then I add. So I get 702. This is my remainder. The last one, because I'm taking a 6th degree polynomial, I know my answer is going to be a 5th degree polynomial. I'm dividing by a linear term, the x minus 3. Remember, synthetic division, it has to be division by a linear term. So I know I'm going to bring the polynomial down by 1 degree. So if I started with a 6th degree polynomial, then I will end with a 5th degree. And remember, we put in those zeros so that we have a number for every term, even if it's 0. So I know that this one is going to be, this 1 represents 1 times x to the 5th. The 3 has a x to the 4th. The 9 has an x cubed. The 27 has an x squared. The 81 has an x, and the 243 is a constant, and this is my remainder. So my quotient, that's a 5th degree. It's 1 degree less than your original dividend. So this is my quotient, q of x, and my remainder is 702. Let's compare now. So that's the synthetic division that we just did instead of that long division. We did exactly the same problem in example 2 and example 3, except I used synthetic division instead of long division. So as you can see, synthetic division goes a little quicker, it's easier, it's multiplication and addition, it's cleaner on your paper, it's not as long. So it is procedural, so you have to memorize how to do it. So that's one con, I guess. Another thing is, for synthetic division, you're restricted to you can't always use it. Sometimes you have to use long division because synthetic division just won't work. And that is because it's so abbreviated. So 1, you have to have the divisor must be in the form x minus a constant. So we had x minus 3. It could be x plus a, and then you just use the negatives. So I could also say or x plus a constant. Your 0, the thing you use over here, is going to be opposite of whatever is here. So when we had x minus a, that means we use a positive a. We have x plus a, then we use a negative a, because we're looking for the 0. All right, and the other requirement is, and this is true for long division as well, you must use those 0 placeholders, because or else I'm taking out all those, the variables, so I need to be able to have a spot for each term, and then that way I can plug them back in. So use 0 placeholders for every missing power. So what I mean by that is, since this right here, let me use a highlighter, this thing was missing an x to the 5th term, I had to use a 0. So I have every power represented. So this is as opposed to, this is a restriction on synthetic division, whereas you can always use long division. So for example, this problem we just did, we had the choice. When I got this problem, this, or I got it up here, then I had the choice. I said, oh, that one works. I could use long division or synthetic division on that one. But our first problem, where I had x cubed minus 8, that is not a candidate for synthetic division because it's not in the form, sorry, not the cubed. This guy is not in the form of x minus a. So this one, you cannot use synthetic division, since the divisor is not in the form of x minus a or x plus a. Sorry, my handwriting is very rushed today. There you go. Okay, so that is division. All three of these we had a remainder, which means we didn't find a factor of the quotient. So I'm going to do one more recording from section 4.3 that has a division problem with no remainder, so we can see what happens and what that means about the polynomial. So this recording actually covered a bit more than the long division. It made it a lot longer than I intended. So this covered 4.31 and 4.32. So it actually covers 51 through 60 as well as, okay, so homework 51 through 60, you have to choose if you're going to use long division or synthetic division. So example 2 and 3 is a good example for that. And then homework numbers 31 through 50 are just those are all synthetic division. So example 3 is good for 31 through 50. And then for 51 through 60, you can decide if you want to use synthetic or long division. And you'll have to decide if it qualifies for synthetic if you want to use synthetic. And if it doesn't, you'll have to use long division. All right, so that wraps up the how to divide even when you have a remainder section.